In previous videos in the playlist linked below the like button, we talked about dynamic memory allocation. Well, let's do some smart pointers so that we can avoid memory leaks. If you remember in the last video, we talked about how we have to delete all of these dynamic memory allocations that we make so that we don't avoid any memory leaks. Well, what if you have some that automatically delete for you? There's 3 types, and we're going to go over unique pointers in this video. Check out the next videos in the playlist link below the like button for shared pointers as well as weak pointers. Those are important as well. But first, let's use smart pointers to avoid memory leaks and talk about unique pointers. So a unique pointer is a smart pointer that owns a dynamically allocated object, and it ensures its deletion when the unique pointer goes out of scope. So if you're like an if statement and you make this unique pointer inside of that if statement, well, once you leave that if statement, you don't have to worry about deleting it. It's already deleted. All the memory that was allocated to it, no longer allocated to it. Same thing with a while loop, same thing with a method, whatever have you. Automatically gets rid of it, so it avoids memory leakage. If we look at our unique pointers right here, we have the unique pointer type, we have our variable type, the little triangles, we have the name. This is whatever you want to call it. I like to call it pointer, and what it is, pointer int. Be descriptive here, and then you're going to pass in what memory you want to allocate to it. I'm allocating a new integer to it. So you can see that I have this asterisk pointer int. That means I can store a value at this address. I'm storing 54. Now I'm going to see out. It's going to print 54. It's going to print some stuff from up here from previous examples. Don't worry about any of that. You can see this first 54 is printed right here. Now, unique pointer owns the object it's pointed to, and there can only be one unique pointer owning a particular object. However, you can actually move ownership to another smart pointer. So let's make a new unique pointer here. It's going to be of type int. We're just going to call it pointer int2, and then we're going to have this move operation. So we have this move method, and inside of it, we just pass our previous unique pointer. Now, I have this cout right here, where I'm going to print our new print int2. But let's comment that out for now because, well, it's printed it here. You can see that's the output. As a matter of fact, if you want, let's do +10, and we can run this. And then, yeah, let's just run this first. And you'll see that it's going to print out a 64 because it's just adding 10 to it and printing it out. Now let's comment this out, and I'll show you that after we move this, if we try to print the original print int right here, nothing is going to print. And that is because there's nothing in it. So it'll print the 54 from here, but it's not going to print anything after that. You'll see it is empty. You can also set to a null pointer if you're not using it currently and you want to use it later before it gets deleted. So I set print int equal to a null pointer. If you do like print int2 is equal to null pointer, and then I just realized I spelled these wrong. I was about to set that to a null pointer. Let's do part int2 is equal to null pointer, and let's try to print this out. So we'll do a cout here, and we'll comment this out to remove any type of confusion. So let's see what we get after we set this to a null pointer, which means that we lose this 54. This 54 data is lost because it's no longer stored in the original part, and it's no longer going to be stored inside of here. So you can see that we originally printed this 54 from line 45. However, since we set it equal to a null pointer, even if we add 10 to it, it's still going to be a null pointer. So it's not printing anything here. Remember, if it goes out of its scope, once it leaves this function, it's going to automatically deallocate any memory. So we don't need the delete function as we've had previously. So you can use these for integers, other data types. For an array, it's pretty similar. You're going to have your unique pointer, as always. Inside of your little triangles, you have your array type. And of course, you have to have the brackets because it's an array. Call it any name you would like. And you're going to set it equal to a make unique, where you're going to pass in the integer type, and then you can pass in whatever size you want. And then you can call different values from here. To add values to this, you could use a for loop if you wanted to. We'll do int a is equal to 0. We want to run this as long as a is less than 5, and we'll have our a plus plus. So inside of here, we're going to have our array pointer, and we're going to have the a index. Let me spell pointer correctly for once in my life. And we're going to set it equal to a, we'll just do a plus 1. Make sure you have your parentheses so your header is closed off good. Now let's run a for loop so that we can print this. So we have a for here. We'll just do a cout, and we're going to have our array pointer a with a space after that. So you can see at the a index, we're storing a plus 1. And then here we're just going to print out the elements with regards to the a index. Oh, But you gotta remove this print right here, because if it tries to print something that's a null pointer, it's going to kind of stop the program, and you don't want that if you want it to continue to run. So after we've cleaned up our code, you can see that we printed out 1, 2, 3, 4, 5 as we wanted to. That's going to be it for unique pointers. In the playlist below, we'll go over shared pointers and weak pointers, and if you want more C++, check out the playlist link below the like button. If you have any questions on this material, leave a comment below.